Okay, this is a vodcast on how to do the first problem on the kinetic and potential energy worksheet. They are total energy problems. As learned earlier in class or on the web page, if you were asked to calculate total energy, you cannot do it in one calculation. It needs to be broken down in steps. And the best way to do it is to draw a time temperature graph. When you draw a time temperature graph, there's going to be some steps that you're going to want to take in order to label it properly so you can understand where you are in this problem. So assume that you have 126 grams of ethanol and it's starting at negative 9.7 degrees Celsius, and then you heat it to 100 degrees C. I'm asking for you to find the total energy in kilojoules. So the first step that you should do for calculating total energies is that you should label the states of matter on the time temperature graph. So that means solids, liquids, and gases. Label the parts of the gas where there's kinetic energy and where there's potential energy. That will help you to determine which equation to use. Label the plateaus with the appropriate boiling point and melting point values. And then finally, I have students place a star on the starting temperature and on the ending temperature. So we're going to look at this first problem, and this is exactly how it looks on your worksheet. You have 126 grams of solid ethanol at a negative 9.7 degrees C, and you're going to heat it to 100 degrees C. I'm asking you to find the total energy in kilojoules. Well, the first step that I talk about is that we should label the states of matter. This represents the solid portion of the ethanol, this represents liquid, and this slanty line represents the gas. The second step is to label either kinetic or potential energy. So the kinetic energy is where it is slanty. That's the slanty line that's indicating that it's warming. Potential energy is the plateau. So this is the first plateau, and this is the second plateau. These would represent the boiling points and the melting points. So here's the melting point of ethanol. Here is the boiling point of ethanol. The third step says that you should label those. So we do appropriately. Where can you find this information for boiling points and melting points? You can find them in that yellow packet you received in class, which is on page 3 in that thermodynamic packet that you have. So I look at ethanol, because that is the substance we're working with here, and I look at, this would represent a boiling point, or excuse me, a melting point, and I look up the melting point for ethanol on that yellow paper you got in class, and indeed I find that it is negative 9.7 degrees C. That is the melting point for ethanol. The boiling point for ethanol is also on that table. It's 78 degrees C, and I label those plateaus. Finally, the fourth step says that you should place a star on the starting temperature and the ending temperature that is given in the problem. So here, the starting temperature is negative 9.7 degrees C. So I put my first star right here in green, and notice that I include the plateau. So I'm going to want to include all of this energy it takes to melt the ethanol. And then the final temperature is 100 degrees C, so that's somewhere above the boiling point of ethanol. I'm just going to put that right here. So now we're at the point where we could start doing the calculations. So the first piece is that we're going to have to calculate from here to here. And you notice that that is a potential energy. Because it's a plateau, we're doing a phase change, and the phase change that we're doing is melting. You're given 126 grams of ethanol, so the first thing you should do is convert that to moles. So I'm going to show that work right up here. 126 grams of ethanol, the molar mass of ethanol is 46.01 grams, and I find out that that's 2.74 moles of ethanol. I now can start doing my potential energy work. So I'm going to look at the phase change for potential energy going from a solid to a liquid, and I'm going to use the delta H of fusion. I look on that yellow paper and I find that that has a molar heat of fusion of 8.30 kilojoules per mole. So I'm going to then take that 2.74 moles and I'm going to apply the delta H of fusion, which for ethanol, which is 8.30 kilojoules per mole, and I come up with 22.7 kilojoules. So I've now calculated the energy it takes to go between this green dot and here. Okay, so there we go. The second step then is going to be heating. I'm going to be heating my liquid ethanol, and this would be a kinetic energy problem. So now we're going back to using that MCAT. To solve that, I will take the kinetic energy is equal to the specific heat, which happens to be 2.44 joules per gram degrees C for liquid ethanol. Where do I find this value? This is on page 2 of that yellow packet you received in class, times the mass of the ethanol, which is 126 grams, times the delta T. The delta T would be the temperature differential between negative 9.7 and 78 degrees, which is 87.7 degrees C. I do that work, and I come up with 26,900 joules, which becomes 26.9 kilojoules. So I now have calculated the energy to heat my liquid ethanol. I'm now at another plateau. With this plateau, though, I am going to calculate the energy required to boil ethanol. So when I look at my molar heat of fusion, or excuse me, my molar heat of vaporization on that yellow paper, I will use the 2.74 moles that I calculated, but now the delta H of vaporization for ethanol is 40.4 kilojoules per mole, which turns then into 111 kilojoules. So I am now to this point right here. So finally I can get to calculating the kinetic energy associated with heating the gas. So I take my kinetic energy, this again is the MCAT formula, which is the specific heat, which is 1.42 joules per gram degrees C, to calculate, times the 126 grams of solid ethanol I had, times that delta T, which is now only 22 degrees C. Where did I get that from? Well, 78 from 100 is 22 grams, so that is, or 22 degrees C, so that is the delta T, which comes out to be 3,936 joules, which turns out to be 3.93 kilojoules. I asked you to calculate total energy, so at the end you would add up all of the energy components. I've asked for it in kilojoules. So you take the 22.7 kilojoules plus 26.9 plus 111 plus 3.9 kilojoules, and you will come up with the answer of 164.5 kilojoules. It's the total energy needed to heat that 126 grams of solid ethanol from negative 9.7 to 100 degrees C. I hope this helps, and good luck.